To the first day of this unit, we will be talking about factoring. All in all, we're going to learn 4 kinds of factoring. We're doing the first 2 today. This should be review from last year, so you shouldn't be looking at this thinking that it's something that you haven't seen before. The first kind of factoring that we're going to be talking about is this GCF factoring, which stands for greatest common factor. You find all the things that each term has in common and you pull them out. The GCF should always go in front of a set of parentheses with all the leftovers inside of it. So when I look at question number 1, I can see that I can divide a 5 out of both terms, because 5 is divisible by 5 and 15 is. The most amount of x's I can take out is x squared, and I can take a y out of each of them. That becomes my GCF. What I get for my leftovers is going to go in parentheses. In order to figure out what your parentheses are going to have in them, you essentially are dividing both of the terms of your original problem by the GCF. So when I do the dividing, in the first term, 5 divided by 5 is 1, so you could write a 1 if you wanted to. And then you have this x to the second and x to the third, which leaves you an extra x. So the 5's cancel, and then the y's cancel also. So when you go through and you do that division, the only thing that you have left is just an x. For the second term, when I do 15 divided by 5, I get 3. There's an x squared on top and bottom, so those cancel. There's a y on top and bottom, so those cancel. So my final answer is 5x squared y, parentheses, x minus 3. And you might want to move your parenthesis over so that it looks a little more complete. In the next question, we're looking for the GCF as well. And I know that the largest number that goes into the 12, the 20, and the 28 is 4. And the most amount of x's that I can take out from each of those terms is an x to the first. It's always going to be the term that has the lowest exponent on it that you're going to pick to be the variable part of it. So because x to the first is the lowest exponent, x to the first is the GCF. So I'm going to put that out here. And you can write a first there if you want to, but you don't have to. And then again, we're doing the same thing. We're going back and we're essentially dividing each term by 4x. And when I do that dividing, 4 goes into 4 once and into 12 3 times, and x to the third divided by x to the first on bottom gives me x to the second. The rule is that you subtract the exponents. So 3 on top, 1 on bottom, 3 minus 1 is 2. So 3x squared is my leftovers from the first term. The next term, I say 4 goes into 4 once and into 25 terms, 5 times. X to the first on bottom, x squared on top, which is going to leave me an extra x when I divide. And then when I go to the last term, the x's cancel, they're the same. 4 goes into 28 7 times, so minus 7. And that becomes my answer. When I move on to the next one, I don't just have x's again, I have x's and y's, so I want to take that into consideration. So my GCF is, for 30 and 6 is 6, so 6 is going to be part of my GCF. The most amount of x's I can take out of both is x squared. Remember, you look for the smallest exponent. One is x to the third and one is x squared, so it's x squared. And then the same thing happens with y squared. It's the smallest exponent on y, so that's going to be what the GCF is. I go back, write this down. I'm dividing both of those terms. So when I do this, I say 30 is divisible by 6 5 times. I have an x to the third and an x squared. It cancels and leaves me an extra x on top. Y to the third and y squared leaves me an extra y on top. So my result from that division is what goes in the parentheses as leftovers. And then from there, 6 cancels with 6, x squared, y squared, y squared. So this is just going to give me a 6 divided by 6, which is 1. Anytime you have 2 terms that are exactly the same and they're being divided, you have to remember to put that 1 in there. We're going to move on and talk about difference of 2 perfect squares factoring. We call that dots. The D for difference of is the O, 2, T, and then squares. So what has to happen is you have to have two terms. That's what the 2 comes from here. There's got to be two terms, and both of the terms have to be perfect squares. So if it's a number, you can only have numbers that you can take the square root of. If there's a variable, the variable has to have an even exponent. The rule for this is you make two parentheses that look identical to each other except for the sign in the middle. And then to get the terms that start and end your parentheses, it's going to be dependent on what your original problem starts and ends the parentheses with. So essentially, I'm square rooting 4x squared. The square root of 4 is 2. The square root of x squared is x to the first. So both of my parentheses start with that same thing. The square root of 9 is 3. So both of my parentheses end with 3. And the rule is you have opposite signs in the middle. So one's a plus and one's a minus. In question 5, same exact thing. This time though, we have the square root of x to the 8th. And just as a little note, if you are taking the square root of x to the whatever the exponent is, if it's even, the answer to that is you take the exponent and you cut it in half. So for this particular question, when I go through and do this, the square root of 100x to the 8th will be 10, the square root of 100, x to the 4th. So both of my parentheses start with that. Square root 49, 7, opposite signs. And then the square root of y to the 10th is y to the 5th. And again, you take the square root of y to the 10th, the exponent is 10, and you cut it in half. For question 6, they don't have any numbers in here, it's just variables, and they're both exponents of 2, so that makes this a very easy question. I'm going to do y and y, the square root of y squared is y, square root of z squared is z, and one is a plus and one is a minus. And then the last question that we have here, question number 7, notice that your problem starts with a 1. The square root of 1 is 1. A lot of times kids will like to see the variable come first, but if your problem starts with the number, your parentheses have to start with the number. And then the square root of m squared is m, so 1 plus and 1 minus. In the next section, please notice that the directions say these are not dots problems. A lot of times kids think that they are. So when we look at why these are not dots problems, you want to go back and remember what the rules are. You have to have two terms in the problem. Both parts of the term have to contain only things that are perfect squares, and there has to be a difference between your two terms. So the D stands for difference. So in question number 8, this is not a dots question because the x has an odd exponent on it. That doesn't work. So I'm going to put, for my reason on why this doesn't work, I'm going to put that it's because the exponent is not even. It has to be even in order for it to work. In question 9, the reason why this is not a dots question is because of the plus sign that's here. So I'm going to put that the sign isn't a negative. And it has to be in order for it to meet the dots rule. And then for question 10, the reason why this is not dots is because the number at the end, the 2, is not a perfect square. In the next section of the notes, they give you a chance to practice a couple of GCF and a couple of dots problems. I'm going to ask you to please pause the video now so that you have time to work on the next 2 sections of questions. So they're at the bottom of this page and partway down on the next page. So I'm going to ask you to do questions 11 through 18 on your own. And then I'm going to have you come back and look at the video again to check your answers. So now that you've unpaused it, I'm going to give you a couple minutes to check answers in each section. Now that you're done with this video, you can use the rest of your class time to work on your homework on this particular unit.